Now that we've got our input map mapped to the WASD, we need to add our character's gun. It looks a little bit funny with the character walking around and only having the one arm. So we're going to fix that right now. So first let's create a new scene, and we'll just do a node 2D scene. And we'll have some review in this lecture as well. So we'll do player gun, and we'll attach a new sprite. And we don't want the offset to be centered, so turn off centered. And we want to find the player gun sprite right here and drag and drop that texture onto the sprite. It should look like this. Now we can determine, because we're going to be rotating this, and we can determine where this rotates on based on its position relative to its parent, the player gun here. And so we're going to turn on use pixel snap, click on the gun and hold control, and then set our rotation point, set the gun to this position, which is -2 and -2, and that will create our rotation point right here. You can see if I hold control outside of the gun and rotate like this, click and rotate, you'll see our pivot point. So we're also going to attach to the sprite here a position 2D node, and this is going to be the muzzle position, basically where we fire the bullets from. And we'll just call this muzzle. And we can drag this and hold control again and stick it right here. And that transform should be 13 and 2, just like this, 13 and 2 on the muzzle. We can now save this into the player folder here and attach a new script to it. It will be called player gun, create, and save that as well. Once we've done that, we're going to get rid of this except for the process function here. We're actually going to use this, so I'll uncomment that. And we'll say var player equals get parent. And then we'll say rotation. So our current rotation equals player dot get local mouse position. So that's going to be the mouse position relative to the player, and that will return a vector for us. Dot angle. So that'll get the angle of the mouse position relative to the player, like that. Now we've got our gun. If we come into our player, we can now attach this scene to the player. So we'll come into right here. We'll add a new scene, instance of scene here, and we'll do player gun like that. And that's obviously not where we want it. So we're going to actually attach it to the sprite. And the reason we're attaching it to the player's sprite is because we want the gun to flip when the character flips, when the character's sprite turns, when it faces right or faces left, we want the gun to flip with it as well. And we're going to set the gun, we're going to set its transform to 1 and 3. And that will put it just in the right spot. And we can save this and run the game. And you can see it now pivots in the correct spot. And it does flip with the player. You can see how it flips with the player. But it flips to the different sides, basically the position flips. But it looks weird because the gun is in front of this sprite. But we need it to be a child of sprite. So we've kind of got a problem here, because we can't put it in a different location in the scene tree over here to put it in front of or behind, but we need it behind. So there's a property inside of most nodes under visibility where you can check this little box here called show behind parent right here. And when we do that, it puts the gun behind the sprite, which is the parent of the gun. And now we've got a much better looking position. But we want to change our character so that the character faces towards the mouse all the time. The gun is facing the mouse, but the character isn't, and so that looks weird. So we'll come into our player right here, and down in our update animations function, we're going to change how this works. So instead of altering the sprite's X scale based on the input vector, we're going to alter the sprite's X scale based on the mouse's position. So we'll say sprite, and we'll do it outside of this right here because we want to do it all the time. So sprite dot scale dot x equals sign get local mouse position dot x. So this will get our mouse position relative to our position. And then it will return the sign, which will either be +1 or -1. So if the mouse position is greater than ours, we'll get a +1 and our scale will be 1, so we'll face to the right. If the mouse's position is less than ours, we'll get a -1. It'll return -1 for the sign, and our scale will face to the left. And we can get rid of this. And that's all we need in order to get the character to face the mouse all the time. So that already looks much better. But the problem is when we move backwards like this, our character animates like he's walking forwards. And it looks weird. So we need to fix that. And the way we can fix that is by altering the playback speed. And so we'll do that right here. We'll say sprite animator dot playback speed. So this is the playback speed for the animator. When we're walking backwards, we want it to play in reverse, so -1. And we can just use, we have to do a little bit of tricky math here, which is we have to get our input vector, which is the direction we're going, and we have to multiply that by our scale, which is the direction we're facing. And that will give us the proper playback speed, either 1 or -1. So we'll say input vector dot x times sprite scale dot x. So I'll try and explain this. Sprite dot scale dot x, like that. I'll try and explain this a little bit more clearly. So if our input vector is 1, that means we're going to the right. Okay? But that in itself doesn't tell us which way we need our animation to play, it forwards or reverse, because we also need to know which way we're facing. So let's say we're going to the right and we're also facing to the right, then this is going to be 1 and this is going to be 1. So when you multiply them by each other, you're going to get 1, which is what we want. If we're going to the right and we're facing the right, then we want to play the animation forwards. However, if we're going to the right and we're facing left, right here, this will be -1. So then we'll play the animation backwards. But that's what we want because we're going to the right, but we're facing left. So we want that character to walk backwards. And of course, it works in the opposite, on the flip side too. Let's say we're going to the left and we're also facing left. These are both going to be -1. And that's going to end up being +1 in the end. But if this is -1 and this is +1, because we're going to the right but we're moving to the left, then we'll play the animation in reverse. So yeah, it's a little bit sneaky, but it's not too bad. And then we need to make sure that whenever we're in our idle animation, we set our playback speed. I'm just going to copy this. We need to set our playback speed equal to 1. Because the idle animation shouldn't ever play in reverse. It should always play forward. So here's our idle animation. Here we are walking forward. Here we are walking backwards. If I face this way and walk backwards and forward, you can see it properly animates the character. And this already feels pretty cool because now it feels like we can kind of aim the gun and move around with WASD. And it just feels more like the character is complete now, where our character was lacking a little bit before. So that's going to be it for this lecture. Hope you enjoyed it, and I'll see you all in the next one.